So now we want to talk about finding limits algebraically or analytically. Again, when you get the indeterminate form, but this time when you have an expression that involves a radical of some sort. Sometimes you will have an expression that has a binomial with either one or two radicals in it, in which case we're going to use the conjugate to help us with that, and hopefully you all remember what a conjugate of a binomial is. And the other case really doesn't have a lot to do with limits at a point as much as it does limits at infinity. But we're going to talk a little bit about simplifying radicals now, and then we'll bring it up again in a later video. So let's start with an example. Suppose you want to find the limit as x goes to 3 of the expression square root of x plus 3 minus the square root of 6 all over x minus 3. Well, we're going to do our usual. We're going to do direct substitution. We're going to put in 3 wherever we have x. So we have 3 plus 3 minus the square root of 6 all over 3 minus 3. And the square root of 3 plus 3 is the square root of 6. Take away square root of 6 is going to leave us with 0. And 3 take away 3 gives us 0. Ding, 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 ding. Indeterminate form. We need to do something more. And our do something more is to try rationalizing by taking the conjugate. This time we're going to rationalize the numerator. By using the conjugate. And I'm going to go to the next page because I didn't leave myself any room on this page. Okay, so we're starting with our expression. The limit as x goes to 3 of that lovely expression. And I want to try to rationalize the numerator, because that's where my radical expression is, by multiplying top and bottom by the conjugate. And we, of course, remember that a conjugate is simply the binomial with the opposite sign in between the terms. And I'm going to do the same thing on both the top and the bottom. But I am not going to actually multiply through the denominator. I'm going to leave those two expressions in parentheses, kind of leave them alone. So that will give me the limit as x goes to 3. When I multiply the numerators, I'm going to first of all multiply square root of 3 square root of x plus 3 times the square root of x plus 3, which is just going to leave me with x plus 3. Then I'm not going to have an outer and an inner term because that's what a conjugate does. It eliminates that part. I'm going to have a negative times a positive, which will always give me a negative. And then finally I'll have radical 6 times radical 6, which will just give me a 6. And the denominator, I'm just going to leave these the way they were. That expression times this expression. I'm not going to actually try to multiply them out at all. But I am going to notice that my top really says x plus 3 minus 6. That top really says x minus 3. So now I have an x minus 3 in the numerator and an x minus 3 in the denominator, and I can take those expressions and I can factor them out, remembering, of course, to always leave my little 1 behind, which means that I am now left with the limit as x goes to 3 of 1 over the square root of x plus 3 plus the square root of 6. I've eliminated the issue that gave me the 0 over 0, plugging 3 in, because now that x minus 3 is what gave me 0, it's gone. So now I can once again do direct substitution, and I will get 1 over the square root of 3 plus the square root of 6, which is 1 over the square root of 6 plus the square root of 6. And 1 square root of 6 plus 1 square root of 6 is 2 square roots of 6. So that's what happens when you have a binomial expression that has either 1 or 2 radicals in it. You have to use the conjugate and work through the problem. On the next page, I'm going to show you an example of simplifying a radical, but we're not going to really talk about the limit at this point. I just want to mention it because we're talking about radicals. the biggest misconception that most people have is the square root of x squared. Technically, it really isn't just equal to x. Technically, it's equal to the absolute value of x. So that if I have an expression like the square root of 4x squared, I really could rewrite that expression as the square root of 4 times the square root of x squared, and I know that the square root of 4 is 2, and the square root of x squared is the absolute value of x, and I could solve my problem that way. Keep that in mind as we go forward, that this is a really important concept that most people don't think about mathematically, and we'll come back to that at a future video.